and welcome to my presentation. My name is Arthur Carvalho. I am an assistant professor at Farmer School of Business at Miami University of Ohio. This is a joint work with Lucas Harris from the same institution. Our work is called Off-the-Shelf Technologies for Sentiment Analysis of Social Media Data, two empirical studies. So let's start with some research background. Research years have seen the rise of low-code/no-code programming paradigms. The main idea here is that organizations can rely on non-technical professionals to develop enterprise-level applications, and the goal is to have a quicker and cheaper way to meet an organization's information technology needs. But the same phenomenon now is moving towards AI and machine learning techniques. Now we have many platforms that offer access to this AI and machine learning technologies. The only thing that's required will be API calls. And as such, all the complexity behind the technologies are hidden from the user using that technology. We call these technologies off-the-shelf AI technologies. In our specific research, we are interested in off-the-shelf AI technologies for sentiment analysis. These off-the-shelf AI technologies for sentiment analysis, they tend to be very cheap. Just to give you one specific example, you can see how Amazon Comprehends offers 50,000 units, text units, to be classified or analyzed for free. From that point on, it charges 0.0001 American dollars per unit for the first 10 million units. And that value drops even further when we analyze more and more texts. But our overall research question in this paper is how accurate are off-the-shelf technologies for sentiment analysis? Are there specific cases when these technologies work better? So we have two studies involving social media data. The first study, we have short texts. These are tweets. The second study, we have Facebook posts. These are longer texts. We analyze 5 different technologies/techniques: IBM Watson Natural Language Understanding, Amazon Comprehend, Microsoft Text Analytics, and Google Natural Language. The last technique that we analyze is the bag of words approach. In a nutshell, what the bag of words does is it takes one entire text and just analyzes individual words. For every single one of the individual words, it classifies the words as either positive, negative, or neutral. Then the sentiment behind the text will be just the sum of the sentiments behind each individual word. So our experimental setup for both studies is defined as follows. First, I emphasize that we do not perform any pre-processing of the data. We take the data as it is and send the data to the off-the-shelf AI technology. Since the sentiment scores provided by these different technologies differ in terms of range, we decide to discretize every single one of these scores returned by each technology. So we now assign labels based on the original scores, and these labels are called a negative, neutral, or positive. After we get these labels, we compare these labels per technology against labels provided by human beings. And now we can define the overall accuracy of every single technology. In a nutshell, we compare the labels provided by technology against the labels provided by human, and we define how close these technologies are to human judgment. Let's go to our first study now, which uses data from Twitter. In our first study, that's about the problems that major US airlines face. We collected a total of 10,380 tweets. The average length of a tweet at that point in time was 107 characters, the standard deviation being approximately 34. The max and mean length are respectively 176 and 12 characters. Each tweet was scored by at least 2 crowd workers from Crowdflower. Crowdflower was a crowdsourcing platform that's now called Figure 8. And then the ground truth labels were derived based on the average scores provided by these human beings. That's the results that we obtained in our first study. Let's focus first on the overall accuracy. You can see that the overall accuracy, perhaps the most important point here, is that every single one of the technologies outperformed the bag of words approach. We do some statistical analysis in our paper, and actually all these differences are statistically significant. So the bag of word approach really underperformed in this study. Another interesting point here is that the accuracy on positive texts, these are texts labeled as positive by human beings, the accuracy here for these technologies are overall, not for all of them, but for most of them, are much higher than the accuracy for negative posts. And the accuracy for negative posts are actually higher than the accuracy for neutral posts. So it seems that technologies do much better when classifying positive rather than negative posts, and likewise negative rather than neutral posts. We now move to our second study, which uses data from Facebook. Just a bit of information about our data set. These are comments on Starbucks' public page on Facebook from a few days before to a few days after Starbucks pledged to hire thousands of refugees in 2017. This comes from another paper of mine, and I have the reference listed here down below. A total of 3,000 plus posts were used in this second study. The data was scrapped between January 15th and February 13th in 2017. The average post length is 205 characters. The max and mean are 2,700 plus and 8 characters. You can see how we have now much longer text than what we used before. Each post was labeled by 5 crowd workers from Amazon Mechanical Turk, and ground truth labels were defined based on the majority vote rule. The same results we discussed before are true here as well. So these technologies tend to do much better in positive texts rather than negative texts, and in negative texts rather than neutral texts. So once again, these technologies tend to struggle tremendously when it comes to classifying texts that are neutral. Another interesting point here is that the overall accuracy of the technologies dropped tremendously in relation to our first study. So let's summarize our results now. Our main findings in these 3 studies are: number one, off-the-shelf technologies greatly outperform the bag of words approach in terms of overall accuracy. So in our opinion, it makes no sense to continue to use the bag of words approach in IES research, because again, we have these technologies that are ready to be used and they provide much better accuracy. The second important finding here is that these technologies perform the best when classifying positive posts and the worst when classifying neutral posts. The third main finding is that these off-the-shelf technologies underperform in terms of the overall accuracy when analyzing longer texts in comparison to shorter texts. That makes kind of sense because you think about a longer text, you can have mixed sentiments throughout the text in different sentences, and shorter texts, they tend to be straight to the point and have only one sentiment. And finally, no single technology consistently outperforms all the others when determining different types of sentiments across the 2 studies. In terms of future work, what we're doing now and what we plan to do in the future is, first, can we compensate for weak individual performance by these technologies by building ensembles of off-the-shelf technologies? So instead of having just one technology now, what if for every single one of the texts we have potential many classifications and we combine these classifications in a way that makes sense? Can we get higher accuracy now? The second research question that we're working on concerns tailored models. Can we get considerably higher accuracy by using tailored models as opposed to off-the-shelf pre-built technologies? By tailored models, what I mean here is some cloud platforms now allow developers to train models in a way that is incredibly easy. The only thing the developer has to do is to upload a data set with 2 columns. One column will be the text to be analyzed, the other column will be the corresponding label. Behind the scenes, the platform will build a model using proprietary training algorithms, and now the developer can use this tailored model. Of course, these services are considerably more expensive, but we believe the accuracy will be much higher. So in future work, we want to analyze these cost benefits of using these tailored models. That's it for my presentation. Thank you so much for watching me. And if you have questions, comments, or if you want to join my ongoing research, feel free to reach out to me. That's my email in my screen now, as well as my LinkedIn page. Thank you.